On September 16, 1975, a semiconductor company from Pennsylvania arrived at the Wescon trade show in San Francisco and discovered it was not allowed to sell anything on the exhibition floor, so the team improvised. They rented a suite at the St. Francis Hotel across the street, left one employee at their booth to hand out directions, and set up 2 glass jars filled with microprocessor chips on a table in the hotel room. The chips were priced at $25 each. At the time, Intel was selling its 8080 for $370. Motorola wanted nearly $200 for the 6800, and here was a company nobody in the industry had heard of, offering a processor for roughly 1/7 the going rate out of glass jars in a hotel suite. Chuck Peddle, the lead engineer behind the chip, later admitted something remarkable about those jars. They were mostly filled with non-working silicon. Only enough good processors were layered across the top to cover the bluff. One of the customers who walked into that hotel suite was a 22-year-old Hewlett-Packard employee named Steve Wozniak. He handed over his money and pulled a chip from one of those jars. How many chips Wozniak actually bought that day is genuinely disputed. Different interviews give different numbers, and different accounts name either Chuck Peddle or Peddle's wife as the person behind the table. What is not disputed is what happened next. The computer Wozniak built with that chip became the Apple I. The chip was the MOS 6502, and the company that made it, MOS Technology of Norristown, Pennsylvania, would not survive long enough to see what it had started. You're watching Tech District, where we take apart the companies that built the electronic world, down to the circuit board and the engineer who designed it. If that's your kind of story, subscribe and hit like, because the rise here is just as strange as the fall. To understand how a $25 chip sold out of glass jars ended up inside the Apple II, the Atari 2600, the Commodore 64, and the Nintendo Entertainment System, you have to start with the man who imagined it before it existed. Charles Ingraham Peddle was born on November 25, 1937, in Bangor, Maine, and grew up in a working-class family near Augusta. His father sold farm machinery. After a summer spent working on a road gang following high school, Peddle decided to attend the University of Maine, where he graduated with a degree in engineering physics in 1959. A course in information theory caught his attention and steered him permanently toward the electronics industry. He did a stint in the Marine Corps Reserves, then spent 11 years at General Electric, working his way up through increasingly complex engineering roles and building a reputation as someone who understood both the hardware and the systems it was meant to serve. By the time he joined Motorola in 1973, he was 35 years old, and he was not young, and he was not naive. He had been designing electronic systems for more than a decade, and he understood both the engineering and the economics of what he was walking into. Motorola hired Peddle to do architectural support work on its 6800 microprocessor family. The 6800 was a serious piece of engineering, designed primarily by Tom Bennett and brought to market through considerable investment. Peddle's specific job was to travel the country, giving technical seminars to prospective customers, explaining what the 6800 could do. He was effective at this, but every visit ended the same way. The engineers sitting across the table would produce lists of things they wanted a microprocessor to do inside their products. Industrial controllers and point-of-sale terminals and scientific instruments. And then they would look at the price tag. The Motorola 6800 launched in late 1974 at $360 per unit in small quantities. At that price, embedding a processor inside a consumer product was arithmetic that simply did not work. Peddle heard this complaint from companies like Ford, from instrument makers, from terminal manufacturers, from anyone who built products in volume. He became convinced that if someone could produce a processor for $25, a market would open that did not yet have a name. He proposed a simplified, cheaper version of the 6800 to Motorola's management. They officially told him to stop working on it. This was not a casual disagreement. Motorola had invested heavily in the 6800 and had not yet recouped its development costs. The chip was barely in volume production, and here was an engineer who had been at the company for less than a year, arguing that they should build something cheaper that might cannibalize their own flagship product during a national recession. Motorola's decision was rational in the room where it was made. It was also the decision that handed the personal computer revolution to someone else. MOS Technology had been founded 5 years earlier, in 1969, by 3 former General Instrument executives named Mort Jaffe, John Pavinin, and Don McLaughlin. They set up operations in Valley Forge, Pennsylvania, and the Allen Bradley Company took a majority interest in 1970. The original business was straightforward: provide a second source for Texas Instruments calculator chips. The company's strapline was, "We've turned a technology into a company." For a few years, this worked well enough. Then, Texas Instruments made the move that would traumatize an entire generation of electronics companies. TI stopped selling just the chips and started selling finished calculators, priced below what the chipsets alone had cost their customers. The calculator market collapsed around every company that depended on buying parts from TI. Many of those companies simply disappeared. MOS Technology survived, barely, by picking up contract work wherever it could find it, including manufacturing a custom single-chip Pong system for Atari. But by mid-1974, the company was a small, struggling semiconductor fab in eastern Pennsylvania, producing chips for a market that was vanishing beneath its feet. It needed something new, and it needed it fast. On August 19, 1974, 8 Motorola engineers walked out of their offices and drove east to join MOS Technology. Chuck Peddle led them. Bill Mensch, born in Quakertown, Pennsylvania, a Temple University graduate who had gone on to earn his degree from the University of Arizona, went with him. Mensch had already designed the 6820 peripheral interface adapter at Motorola and was one of the key semiconductor engineers behind the 6800 itself. The rest of the team followed: Harry Bauckham, Will Mathis, Rod Orgel, Ray Hurt, Mike Janes, and Terry Holt. They are collectively remembered as Team 6502. What they found at MOS Technology was a small operation with something the large companies lacked, which was speed and flexibility. Jaffe, Pavinin, and McLaughlin had assembled small teams of capable chip designers, a quick turnaround mask shop, and a high-yielding manufacturing process that could move from new design to working silicon in days, rather than the weeks or months typical at larger firms. Peddle gave the engineers a tight list of features and a fixed die size. No extras. No indulgences. The target price was set before the first transistor was drawn: $25 per chip. The year that followed was one of the most consequential in the history of the microprocessor, and almost none of it happened in Silicon Valley. Bill Mensch took the schematics for the MOS 6501 and created the entire physical chip layout by hand. There were no computer-aided design tools for this kind of work in 1974. Mensch drew every transistor, every interconnect, every signal path, working from paper schematics to a complete mask set that would be etched into silicon wafers. When the first wafers came back from the fab, the 6501 worked on the very first attempt. A fully functional processor from a hand-drawn layout on the first silicon run was, by the standards of the semiconductor industry in the mid-1970s, nearly impossible. Other companies expected multiple revision cycles before a new chip design would yield working parts. Mensch later explained that the key advantage was a depletion load NMOS fabrication process that MOS Technology had refined to achieve roughly 70% good chips per wafer. Their competitors were averaging a fraction of that. As Bill Mensch put it in a later IEE interview, the process yielded 10 times as many good chips as the competition. The trick, Peddle said, was repairing flaws in the photolithographic masks before production began, rather than after. The resulting MOS 6502 used 3,510 transistors. Its instruction set was lean, with only 56 instructions, compared to the Motorola 6800's 72. Everything that did not directly serve real-world embedded applications was cut. One of its most effective design choices was zero-page addressing, which allowed the first 256 bytes of memory to be accessed with shorter, faster instructions, effectively expanding the register set without adding hardware. The two-phase on-chip clock generator meant a system designer needed only an inexpensive crystal and a handful of support components to get a working board running. Many instructions executed in just 2 clock cycles, which meant a MOS 6502 running at 1 MHz could match or outperform competitors clocked at 2 to 4 MHz. The chip was smaller, faster per cycle, and drastically cheaper to produce. The 6501 was pin-compatible with the Motorola 6800. This was deliberate, and it was a provocation. If you had a 6800 board, you could pull the Motorola chip and drop in a MOS 6501 for a fraction of the cost. Some who were there later suggested the 6501 was designed as a sacrificial lamb. The product MOS Technology expected to lose in a legal fight, so that the 6502, with its different pinout, would survive untouched. Motorola responded exactly as expected. In November 1975, 2 months after the Wescon debut, Motorola filed suit for patent infringement and misappropriation of trade secrets. They alleged that Mike Janes had taken confidential documents when he left. Motorola was a billion-dollar corporation with deep legal resources. Alan Bradley, still MOS Technology's majority owner, wanted no part of the fight. They sold their interest in MOS Technology back to the 3 founders and walked away entirely. MOS Technology was now independent. It was also nearly broke. In March 1976, the company settled the lawsuit. They withdrew the 6501 from the market, paid Motorola $200,000 in damages, returned the disputed documents, and agreed to a mutual cross-licensing arrangement covering microprocessor patents. The 6502, with its different pinout, was untouched by the settlement. But MOS Technology had spent every last dollar surviving the legal battle, and the company that had just proven it could design one of the fastest and cheapest processors in the world was running on fumes. Peddle's answer to the crisis was characteristically direct. He built a computer. With the 6501 dead and no existing commercial system designed around the 6502's pin layout, potential customers had no easy way to evaluate the chip. So Peddle designed the KIM-1, short for Keyboard Input Monitor. It was a single printed circuit board, roughly 9 inches by 10, carrying a MOS 6502 processor running at 1 MHz, 1 kilobyte of RAM, 2 kilobytes of ROM containing a monitor program, a 23-key hexadecimal keypad, 6 7-segment LED displays, 15 bidirectional input-output pins, and a cassette interface for storing programs on audio tape. It launched in 1976 at a retail price of $245. MOS Technology built the KIM-1 as a demonstration platform for engineers evaluating the 6502 for use in embedded systems. They were surprised when hobbyists started buying it instead. Peter Jennings wrote microchess on a KIM-1 that year, making it one of the first commercially sold microcomputer software programs in history. The KIM-1 proved something that the chip alone could not communicate. The 6502 was not merely a cheaper processor. It was the seed of a personal computer. Peddle already knew what he wanted to build next. He called it the Pete. But the KIM-1, for all its influence, could not solve MOS Technology's fundamental problem. The company was selling the future for $25 per chip and $245 per board, and it still could not cover its debts. The Motorola settlement had drained whatever capital remained. To understand what happened next, you have to understand the force that was reshaping the entire semiconductor industry in the mid-1970s, and the 2 men whose survival instincts would determine whether MOS Technology's chip reached the world or disappeared into a Pennsylvania warehouse. The trauma that defined the personal computer business was not a technology. It was a business decision by Texas Instruments. TI had sold calculator chips to dozens of companies, including Commodore Business Machines, a Canadian company that Jack Tramiel had built from a Toronto typewriter repair shop into a successful calculator manufacturer. When TI entered the calculator market directly and undercut everyone who had been buying its parts, Commodore nearly died. Irving Gould, a Canadian financier, injected $3 million to keep the company alive. Tramiel, a Holocaust survivor who had been personally examined by Josef Mengele at Auschwitz, was not a man who forgot a lesson. He made a vow that Commodore would never again depend on an outside chip supplier. His strategy had a name: vertical integration. Own the silicon, own the product, control the price. Meanwhile, the personal computer was assembling itself from parts nobody had planned to connect. The Altair 8800 shipped in January 1975 as a $397 mail order kit built around the Intel 8A80. The Homebrew Computer Club was meeting in a garage in Menlo Park. Steve Wozniak was designing a computer on paper because he could not afford a processor until the $25 6502 appeared at Wescon and changed his plans overnight. Before the 6502, the idea of putting a microprocessor inside a product ordinary people could afford was not economically viable. When MOS Technology introduced the 6502 at $25, the shockwave traveled through the entire semiconductor industry within weeks. Motorola dropped the 6800 from $175 to $69, and eventually to $35 by May 1976. Intel held the 8080's price longer, but could not ignore the pressure. The entire pricing structure of the microprocessor industry, a structure that had kept processors out of consumer products since the microprocessor's invention, collapsed in under 12 months. MOS Technology did not enter an existing market. It tore one open and created another. By 1976, Commodore was MOS Technology's largest customer. Tramiel saw exactly what he needed. With Gould's financial backing, Commodore acquired 100% of MOS Technology's equity in September 1976. The New Scientist reported that Commodore, then valued at $60 million on the New York Stock Exchange, exchanged a 9.4% equity stake for a company valued at around $12 million. MOS Technology's chip fab, its engineering team, and its processor family all now belonged to Commodore. The deal changed everything. The Apple I had already launched in July 1976. Wozniak's single-board computer, built around the 6502 he had purchased for $25, selling for $666.66 because Wozniak liked repeating digits. Roughly 200 units were produced. After Commodore acquired MOS Technology, Apple could no longer buy processors from the source and switched to Synertec, a licensed second-source manufacturer. The Apple II, which launched in June 1977 at $1,298, became the first mass-market personal computer. It ran on a MOS 6502 clocked at 1.023 MHz. That same year, 1977, Atari released the 2600 home video game console. It used the MOS 6507, a stripped-down 6502 variant with a reduced address bus, no interrupt lines, and only 128 bytes of RAM. 128 bytes, not kilobytes, bytes. Atari 2600 programmers had to write code that generated graphics one scan line at a time, synchronized to the television's electron beam, in a technique called racing the beam. The tricks they invented to produce colorful, animated games on that hardware remain some of the most ingenious programming in computing history. Millions of Atari 2600 consoles sold around the world, and every single one carried a MOS processor inside. Chuck Peddle convinced Jack Tramiel personally to approve the Commodore PET, which debuted at the January 1977 Consumer Electronics Show, 6 months before the Apple II shipped. The PT was the Kim-1's direct descendant, now fully formed, with keyboard, monitor, and cassette drive integrated into one unit, all powered by the 6502. It was the complete personal computer that Peddle had been imagining since his days giving seminars for Motorola. The Commodore VIC-20 followed and became the first computer ever to sell 1 million units. Then came the Commodore 64 in 1982 using the MOS 6510, a 6502 derivative with a built-in input-output port for bank switching, paired with the SID sound chip and VIC-2 video chip, both designed by engineers at the MOS Technology fab in Norristown, Pennsylvania. Because Commodore owned the chip factory, the estimated production cost of each Commodore 64 was just $135. It retailed at $595 and became the best-selling single personal computer model of all time. At its debut at the January 1982 Winter Consumer Electronics Show, production engineer David Ziembicki recalled Atari employees standing at the Commodore booth, mouths open, asking the same question over and over. How can you do that for $595? When the Nintendo Famicom launched in Japan in 1983 and reached the United States as the Nintendo Entertainment System in 1985, it used the Rico 2A03, yet another 6502 derivative, this time with the decimal mode disabled because Nintendo did not want to pay the patent licensing fee. Super Mario Bros., The Legend of Zelda, Metroid, all running on architecture that traced directly back to 8 engineers who left Motorola and drove to a small fab in eastern Pennsylvania in August 1974. But there was a fracture forming that only the engineers on the inside could see. Commodore had renamed MOS Technology to the Commodore Semiconductor Group shortly after the acquisition, but the fab kept stamping the old MOS logo on every chip it produced until 1989. The Norristown facility could produce prototype chips in days at practically no cost. Companies like Atari, Apple, and Osborne had to spend tens of thousands of dollars and wait weeks or months for the same turnaround. This was an extraordinary manufacturing advantage, and Commodore's management never fully understood what they had. Tramiel closed the Moore Park Research Center in California in a moment of anger, and most of the West Coast MOS engineers, including Chuck Peddle, refused to relocate to Pennsylvania. Peddle left Commodore, briefly joined Apple, returned to Commodore, and left again. By the mid-1980s, Commodore had roughly a dozen certified engineers left worldwide, most of them still working at the old MOS facility in Norristown. The company had the best captive chip fab in the home computer industry and was slowly bleeding out the people who knew how to use it. Jack Tramiel left Commodore in January 1984 over a reported disagreement with Irving Gould. He took the failing Atari Corporation from Warner Communications for almost nothing. Commodore lost its most aggressive competitive strategist at the moment it needed one most. The IBM PC had arrived in 1981 with the Intel 808, and the industry was standardizing around an architecture that had nothing to do with the 6502. The world was moving towards 16 and 32-bit computing. MOS Technology's engineers in Norristown wanted to design a 16-bit successor to the 6502. Commodore's management was apathetic and refused to fund the project. Bill Mensch, who had left MOS Technology in 1977 and founded the Western Design Center in Mesa, Arizona, built it himself. His 65C816, a 16-bit processor backward compatible with the 6502, went into the Apple II-GS and later the Super Nintendo. The company that owned the 6502 refused to build its future. The engineer who had co-designed the original built it on his own, from Arizona. Tramiel's departure can be read two ways, and honest history holds both. Bill Mensch later suggested that Tramiel was far too shrewd to think he simply quit Commodore. Tramiel understood the limitations of Commodore's technology. He knew the impact that IBM, Microsoft, and Intel would have on the home computer market. Whether Tramiel fled a company he knew was doomed or was pushed from one that still had profitable years ahead of it remains genuinely unresolved. The documented record is thinner than the story everyone tells. Commodore went bankrupt in 1994, The Commodore Semiconductor Group, the final institutional remnant of MOS Technology, was sold to its former management for approximately $5.3 million, including about $1 million in expenses covering EPA liens. They reopened the original 1-micrometer fab at 950 Rittenhouse Road in Norristown under a new name, GMT Microelectronics, short for Great Mixed Signal Technologies. Production restarted in 1995. By 1999, GMT had 180 employees and $21 million in annual revenue. 10,000 wafers per month were coming off the line. For a brief moment, it looked like the old MOS Technology fab might actually survive on its own. Then, the ground caught up with the factory. In 2001, the EPA shut the plant down. Underground storage tanks had been leaking trichloroethylene and other volatile organic compounds into the groundwater for years, possibly since the 1970s. The site had been on the EPA's National Priorities list of hazardous waste sites since 1989. The chemicals that had been used to etch and clean the silicon wafers, the solvents that had made the 6502 and the SID chip and the VIC2 possible, had been quietly poisoning the ground beneath the building where those chips were manufactured. GMT ceased operations. Its semiconductor assets were liquidated. The building at 950 Rittenhouse Road sat empty. A company whose processor had powered billions of devices ended its life as an environmental remediation project and a line item in a liquidation filing. But the chip did not die with the company. Bill Mensch's Western Design Center in Mesa, Arizona, has shipped over 8 billion CMOS descendants of the 6502, more than one for every person on Earth. The 65C02 is still in production today. From pacemakers implanted in human chests, to dashboard controllers in automobiles, to the Super Nintendo Entertainment System, the architecture that Mensch laid out by hand on paper in 1974 is running inside devices whose owners will never open the case. Mensch holds 22 patents in microprocessor technology. At a 1996 Comdex ceremony, the MOS 6502 was honored as one of only 7 microprocessors judged to have had the greatest impact on the information technology industry over the previous quarter century. Mensch received the award on behalf of the chip. Peddle was not on stage. In 2020, Bill Hurd, the engineer who had designed the Commodore 128, returned to the abandoned MOS Technology building in Norristown with a camera. The basement was flooded with dirty water. Broken parts from computers he had worked on decades earlier were scattered across the floor. On the second floor, where the engineering offices had been, where design deadlines had once driven engineers through weekends and holidays, someone had made a small campfire. Out the window, there was nothing to see but a golf course. Hurd later showed the footage to a colleague named Dave, and they both smiled at the thought that it was 35 years later. Dave has since died. "The world has one less wizard," Hurd wrote, and as the video shows, the dragon has long since gone quiet. Will Mathis, one of the original Team 6502 engineers, visited the building separately and found devastation. The only evidence he could find that MOS Technology had ever existed there was a 4-inch pipe in the front lawn, painted with the words MOS 15. The users never stopped caring. Original Kim 1 boards sell for hundreds of dollars on the collector market. Working Commodore 64s sustain a cottage industry of repair, modification, and new software development. Hobbyists design and build new hardware around the 65C02 today. The 6502 remains one of the most studied and emulated processors in the world. Researchers at KU Leuven in Belgium fabricated a flexible version of the 6502 on a polyamide wafer less than 30 micrometers thick, proving that the architecture is simple enough and elegant enough to be manufactured on materials that did not exist when the chip was designed. A working original MOS-branded 6502 from 1975 or 1976, the white ceramic package with the purple logo sells for well over $100 to collectors. The people who use these machines and the communities they built outlived the company by decades. They are, in the end, the verdict that matters. In September 1975, 2 glass jars sat on a table in a rented suite at the St. Francis Hotel in San Francisco. Most of the chips inside them did not work. The company that fabricated them would change names 3 times, survive 1 lawsuit, 1 acquisition, 1 bankruptcy, and 1 environmental shutdown before the building where those chips were made was left to flood and rot on a Superfund site in Norristown, Pennsylvania. Chuck Peddle, the man who carried the idea of a $25 processor out of Motorola and into that small Pennsylvania fab, died on December 15, 2019, at his home in Santa Cruz, California. He was 82. Pancreatic cancer. He had grown up in a working-class family in Maine, built a chip that enabled the personal computer age, and never received the public recognition that went to the people who used his work to build their fortunes. MOS Technology built the chip that made personal computing affordable, and the industry that chip created swallowed the company whole. If you ever owned a machine powered by the 6502, or worked at MOS Technology, or at Commodore, or wrote code for any of these systems, drop a comment below. Tell us the model, the year, and whether it still works. The people who use these machines and the people who built them know more about what was lost than the people who sold it. Subscribe, because we have the story of another company that built an empire on silicon and lost it coming next, and you will not want to miss how it ends.